The Next 10 Billion Years by John Michael Greer. Contemporary industrial society loves to preen itself on its rationality, but it's remarkable how brittle the hold of reason really is these days. It's not hard to point to examples of that brittleness. The one I want to explore here is the way the rationality gives way to overt myth as soon as people in the industrial world start talking about the future. Not their own short-term future, but the future of humanity as a whole. Historians and scientists have learned quite a bit down the years about how civilizations rise and fall, how species evolve and go extinct, and what we can expect from the rest of this planet's long trajectory through time. Typically, though, contemporary visions of the future leave that knowledge untouched. Instead, we get endless rehashes of two stereotyped narratives. The story of perpetual progress leading humanity straight to some simulacrum of godhood, on one hand, and on the other, the story of overnight apocalypse leading humanity to planetary die-off, with or without a plucky band of survivors to pose while the final credits roll past. These notions of progress and apocalypse are industrial society's traditional folk mythologies, rather than meaningful ways of understanding the future. Once they're jettisoned and known details of ecology, evolution, and astrophysics are brought in to fill out the story in their place, the next 10 billion years looks very different from either of those overfamiliar scenarios. Here's one version, or if you will, one vision. 10 years from now. Business as usual continues. The human population peaks at 8.5 billion. Fossil fuels and other non-renewable resources deplete steadily, and the annual cost of weather-related disasters continues to rise. Politicians and the media insist loudly that better times are just around the corner, as times steadily get worse. Among those who recognize that something's wrong, one popular viewpoint holds that fusion power, artificial intelligence, and interstellar migration will shortly solve all our problems, and therefore we don't have to change the way we live. Another, equally popular, insists that total human extinction is scarcely a decade away, and therefore we don't have to change the way we live. Most people accept one or the other, while the last chance for meaningful systemic change slips silently away. 100 years from now. It has been a difficult century. After more than a dozen major wars, 3 global pandemics, repeated famines, and steep worldwide declines in public health and civil order, human population is down to 3 billion and falling. Sea level is up 4 meters and rising fast as the Greenland and West Antarctic ice caps disintegrate. Fossil fuel production ground to a halt decades earlier as the last economically producible reserves were exhausted, and most of the proposed alternatives turned out to be unaffordable in the absence of the sort of cheap, abundant, highly concentrated energy only fossil fuels can provide. Cornucopians still insist that fusion power, artificial intelligence, and interstellar migration will save us any day now, and their opponents still insist that human extinction is imminent. But most people are too busy trying to stay alive to listen to either group. 1,000 years from now. The Earth is without ice caps and glaciers for the first time in 20 million years, and sea level has gone up more than 100 meters worldwide. Much of the world has a tropical climate, as it did 50 million years earlier. Human population is 100 million, up from half that figure at the bottom of the bitter dark age now passing into memory. Only a few scholars have any idea what the words fusion power, artificial intelligence, and interstellar migration once meant. And though there are still people insisting that the end of the world will arrive soon, their arguments rely more overtly on theology than before. New civilizations are rising in various corners of the world, combining legacy technologies with their own unique cultural forms. The one thing they all have in common is that the industrial society of our era is their idea of evil incarnate. 10,000 years from now. The rise in global temperature has shut down the thermohaline circulation and launched an oceanic anoxic event, the planet's normal negative feedback process when carbon dioxide levels get out of hand. Today's industrial civilization is a dim memory, as far removed from this time as the Neolithic Revolution is from ours. Believers in the most traditional religions declare piously that the climate changes of the last 10 millennia are the results of human misbehavior, while rationalists insist that this is all superstition and the climate changes have perfectly natural causes. As the anoxic oceans draw carbon out of the biosphere and entomb it in the sediments of the seafloor, the climate begins a gradual cooling, a process which helps push humanity's sixth global civilization into its terminal decline. 100,000 years from now. Carbon dioxide levels drop below pre-industrial levels as the oceanic anoxic event finishes its work. The feedback loops that govern Earth's climate shift again. The thermohaline circulation restarts, triggering another round of climate changes. Humanity's 79th global civilization flourishes and begins its slow decline as the disruptions set in motion by a long-forgotten industrial age are drowned out by older cycles. The scholars of that civilization are thrilled by the notions of fusion power, artificial intelligence, and interstellar migration. They have no idea that we dreamed the same dreams before them, being further in our future than the first Neanderthals are in our past, but they will have no more luck than we did. 1,000,000 years from now. The Earth is in an ice age. Great ice sheets cover much of the northern hemisphere, and sea level is 150 meters lower than today. To the people living at this time, who have never known anything else, this is normal. Metals have become rare geological specimens. For millennia now, most human societies have used renewable ceramic bioplastic composites instead, and the very existence of fossil fuels has long since been forgotten. The 664th global human civilization is at its peak, lofting aerostat towns into the skies and building great floating cities on the seas. Its long afternoon will eventually draw to an end after scores of generations, and when it falls, other civilizations will rise in its place. 10 million years from now. The long glacial epoch that began in the Pleistocene has finally ended, and the Earth is returning to its normal status as a steamy jungle planet. This latest set of changes proves to be just a little bit too much for humanity. No fewer than 8,639 global civilizations have risen and fallen over the past 10 million years, each with its own unique sciences, technologies, arts, literatures, philosophies, and ways of thinking about the cosmos. The shortest lasted for less than a century before blowing itself to smithereens, while the longest lasting endured for 8 millennia before finally winding down. All that is over now. There are still relict human populations in Antarctica, and another 1,000,000 years will pass before cascading climatic and ecological changes finally push the last of them over the brink into extinction. Meanwhile, in the tropical forests of what is now southern Siberia, the descendants of raccoons who crossed the Bering Land Bridge during the last great ice age are proliferating rapidly, expanding into empty ecological niches once filled by the larger primates. In another 30 million years or so, their descendants will come down from the trees. 100 million years from now. Retro rockets fire and fall silent as the ungainly craft settles down on the surface of the moon. After feverish final checks, the hatch is opened, and 2 figures descend onto the lunar surface. They are bipeds, but not even remotely human. They belong to Earth's third intelligent species, distantly descended from the crows of our time, though they look no more like crows than you look like the tree shrews of the Cretaceous. Since you have a larynx rather than a syrinx, you can't even begin to pronounce what they call themselves, so we'll call them corvins. Earth's second intelligent species, whom we'll call scions, after their raccoon ancestors, are long gone. They lasted little more than 8 million years before the changes of an unstable planet sent them to extinction. They never got that deeply into technology, though their political institutions made the most sophisticated human equivalents look embarrassingly crude. Some twist of inherited psychology gave them a passion for heights. They worked out the hot air balloon before they invented the wheel, and balloons and gliders play the same roles in their earliest epic literature that horses and chariots play in ours. As Corvan technologies evolved, eyes gazed upwards from soaring tower cities at the moon, the perch of perches set high above the world. All that was needed to make those dreams a reality was petroleum, and 100 million years is more than enough time for the Earth to restock her petroleum reserves, especially if that period starts off with an oceanic anoxic event that stashes gigatons of carbon in marine sediments. Thus it was inevitable that sooner or later the strongest of the great Corvan kith assemblies would take on the task of reaching the moon. The universe has a surprise in store for the Corvans, though. Their first lander set down on a flat lunar plain that a very long time ago was called the Sea of Tranquility. And so it was that the stunned Corvan astronauts found themselves facing the fragmentary but unmistakable remains of a spacecraft that arrived on the moon in the unimaginably distant past. Those shattered remnants made it hard for even the most optimistic Corvans to embrace the notion that some providence guaranteed the survival of intelligent species. The Corvans never learned much about the enigmatic ancient species that left its mark on the moon. Even so, the stark warning of that ruined spacecraft helped convince the Corvans to rein in the extravagant use of petroleum and other non-renewable resources, though it also inspired expensive and ultimately futile attempts to achieve interstellar migration. For some reason, the Corvans never got into the quest for fusion power or artificial intelligence. One way or another, the Corvans turned out to be the most enduring of Earth's intelligent species, and more than 28 million years passed before their day finally ended. 1 billion years from now. The Earth is old and mostly desert. The increasing heat of the sun as it proceeds through its own life cycle, and the ongoing loss of volatile molecules from the upper atmosphere into space have reduced the seas to scattered, salty basins amid great sandy wastes. Only near the north and south poles does vegetation flourish, and with it the corbicules, Earth's 11th and last intelligent species. Their ancestors in our time are an invasive species of freshwater clam. Don't laugh. 1 billion years ago, your ancestors were still trying to work out the details of multicellularity. The corbicules have the same practical limb structure as the rest of their subphylum. 6 stumpy podicles for walking, 2 muscular dorsal tentacles for gross manipulations, and 2 slender buccal tentacles by the mouth for fine manipulations. They spend most of their time in underground city complexes, venturing to the surface to harvest vegetation to feed the metafungal gardens that provide them with nourishment. By some combination of luck and a general tendency towards cephalization common to many evolutionary lineages, Earth's last intelligent species is also its most intellectually gifted. Hatchlings barely out of the creche get fun little logical problems such as Fermat's last theorem for their amusement, and most adult corbicules are involved in some field of intellectual endeavor. Being patient, long-lived, and not fond of collected stupidities, they have gone very far. Some 8,000 years back, a circle of radical young corbicule thinkers proposed the project of working out all the physical laws of the cosmos, starting from first principles. So unprecedented a suggestion sparked countless debates, publications, ceremonial dances, and professional duels in which elderly scholars killed themselves in order to cast opprobrium on their rivals. Still, it was far too delectable an intellectual challenge to be left unanswered, and the work has proceeded ever since. In the course of their researches, without placing any great importance on the fact, the best minds among the corbicules have proved conclusively that nuclear fusion, artificial intelligence, and interstellar migration were never practical options in the first place. Being patient, long-lived, and not fond of collective stupidities, the corbicules have long since accepted their eventual fate. In another 6 million years, as the sun expands and the Earth's surface temperature rises, the last vegetation will perish, and the corbicules will go extinct. In another 90 million years, the last multicellular life forms will die out. In another 200 million years, the last seas will boil, and Earth's biosphere, at the end of its long, long life, will nestle into the deepest crevices of its ancient world, and drift into a final sleep. 10 billion years from now. Earth is gone. It had a splendid funeral. Its body dissolved in stellar fire as the sun reached its red giant stage and expanded out to the orbit of Mars, and its ashes were flung outwards into space with the first helium flash that marked the beginning of the sun's descent towards its destiny. 2 billion years later, the gassed and dust-rich shock wave from that flash plowed into a mass of interstellar dust dozens of light years away from the sun's pale corpse, and kick-started one of the great transformative processes of the cosmos. Billions of years have passed since that collision. A yellow-orange K2 star now burns cheerily in the midst of 6 planets and 2 asteroid belts. The second planet has a surface temperature between the freezing and boiling points of water, and a sufficiently rich assortment of elements to launch another of the great transformative processes of the cosmos. Now, in one spot on the surface of this world, rising up past bulbous purplish things that don't look anything like trees, but fulfill the same ecological function, is a crag of black rock. On top of that crag, a creature sits looking at the stars, fanning its lunnules with its sagittal crest, and waving its pedipalps meditatively back and forth. It is one of the first members of its world's first intelligent species, and it is, for the first time ever on that world, considering the stars and wondering if other beings might live out there among them. The creature's biochemistry, structure, and life cycle have nothing in common with yours, dear reader. Its world, its sensory organs, its mind, and its feelings would be utterly alien to you, even if 10 billion years didn't separate you. Nonetheless, it so happens that a few atoms that are currently part of your brain, as you read these words, will also be part of the brain analog of that creature on the crag, on that distant, not yet existing world. Does that fact horrify or depress you? Does it leave you cold? Or does it console you to think of yourself as part of the dance by which worlds are born and die?